All right, Algebra 1, we're going to work back into, right? This says 5-3. We just did 5-4 the other day. You're thinking, why are we going backwards in the book, Mr. Toll? Well, I'll tell you exactly why. Well, actually, I'm going to show you in just a minute. All right. So, slope intercept form. Remember, this is the one you came to me and you said, hey, that's y equals mx plus b. It was like, that's awesome. Right? We know that the m is the slope. We know that b is the y intercept. Okay, so that means x is 0 and I get b, right? So that's what happens all the time. So we're going to start making sure we understand that idea. The slope equation, remember, that's y2 minus y1 over top of x2 minus x1, and that gives us the slope. All right, so how do I graph out of it? Remember, I'm going to start with the y-intercept, right? So if I had y equals 3x minus 2, right, I'm going to go down 2, make a point, because that has to be there. It has to be. All right, and then we're going to rise 3 and run 1. 1, 2, 3, run 1. Okay, they connect those 2 points. And that's why we like slope intercept so much, because it's so easy to graph out of. But we're not going to get to that yet today. We're going to work on some other things where I just want you to write the equation. You know, like, all right, we just wrote equations in point slope form. And I'm like, yes, that's exactly what I wanted to hear, because now I know the slope is 1/2 and the point is 8, -1. So to get there, what we're going to do is we're going to write it as y minus the y value, so it's plus 1, -1/2 x minus 8. Boom, gotcha. Oh, wait, it's not in slope intercept form. Right? But doing it this way makes it super easy. And when you're done, you're done. We're going to distribute -1/2. So -1/2 x, negative times negative is positive. Half of 8 is 4. You're like, that's cool, but we thought we're trying to get an answer. We are. Remember, slope intercept form starts with y equals. So if I can just figure out a way to get rid of this plus 1. Oh, you said subtract 1? All right. I can do that. So y equals -1/2 x plus 3. So you're saying that's slope intercept form? Yeah, we rocked it. Good stuff. All right, how do I graph it? Plus 3, 1, 2, 3. Plot the point. Slope is now -1/2, down 1 over 2, down 1 over 2. There it goes. All right, and grand idea, I got to make sure it's a negative slope. It's going down, right? Yes, we got it. All right, let's do that again. We're going to work with a point and a slope. So we're going to work with point slope, but I got to get in the slope intercept form. So that's why maybe you didn't like point slope form so much, but you can see why now we're doing that. So y minus the 5, 2 times x minus the 1, distribute. 2x minus 2 equals y minus 5. Right? I'm supposed to get y by itself again, but right now it's y minus. I know. Yeah, yeah. Just add 5, right? Y equals 2x plus 3. How do I graph it? Whoop. 1, 2, 3. Start with the y-intercept. Rise 2, 1, 2, and run 1. There we go. All right, it is a positive slope line, right? The 2 is positive. It's going up from the left to the right. So that's pretty awesome as well. Okay, so we're going to use that point slope form. That's where we started right here. And if I do that, I don't have to rearrange the equation. So I'm really going to encourage that. If you want to Google a different way to do it, you can do that. But I wouldn't do it if I were you. All right, the next one we got y minus 7 equals -3 x minus 0. That seems weird. What's x minus 0? That's just x, right? So -3x, y minus 7. We keep adding or subtracting this thing, so I'm going to add that 7 over. So y equals -3x plus 7. Huh. Isn't that what I started? Yeah, that's what I started with. So remember, this is one thing that we were talking about is when we were talking about slope is if you had repeated values for x or repeated values for y, right? Those things we're going to start to notice that that can make your life a little bit easier. Would this have been awesome if I said, you know what, this means b equals 7? Boom, right to the answer because I already knew the slope as well. All right, so again, I want to show you what to do if you don't realize that. And then also, what do I do when I get done with it? Um, if I just plug it in, what's going to happen, right? So that's what's going to happen. But if I don't realize it, I can do all the work and I will get the correct answer either way. Okay, so just want to be careful of that. Now, if I had 7, 0, this would have been very different, right? Because that would be an x-intercept, not a y-intercept. So just be mindful of that. 2 points this time. Let's just make up some ordered pairs. Let's go with 5 and -1 and 3 with, let's go with, let's use a +5 on that one. So you're going to start with a y value. Which one do you want to use? So let's go with 5 minus -1. So I'm going to make it +1, all right? So don't let that confuse you. It was minus -1. And if I started with 5, I have to start with 3. So 3 minus 5. You're thinking, wait, this is way different. But if I have 2 points, I don't have a slope. I can't do anything until I know what the slope is. All right, so we get 6 over -2. -3 is the slope. All right, now I have to make a decision, right? I have to use one of these ordered pairs. Okay. Now, there's a reason that your parents don't give you too many choices, because sometimes I find my students, they really struggle with making a choice. So that's why adults just tell you what to do. Okay, so you have to like use this as a way to be like, you know what, I can make good decisions. So what would be a good decision here? Because I have to use the slope, I have to use one of these ordered pairs. Good decision would be use the one that has the same signs, right? So when you go to plug these in, y minus 5 equals -3, x minus 3. Why is that a good decision? I don't have to worry about which sign is which, right? They're both positive, so I know in my equation they're both negative. If I choose 5 and -1, I have to remember to change the signs, and they're both going to be one of each. So that might be kind of something extra to remember, but you can do this either way. All right, so let's distribute -3x plus 9, y minus 5. All right, and to get rid of the minus 5, we're going to add 5. Whoop, there it goes. Y equals -3x plus 14. Well, that one worked out pretty well. Okay, so let's get a quick little sketch. I'm going to put my x-axis really low. So we're going to call this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It fits. There we go. And we're going to go down 3, 1, 2, 3, and over 1. And that looks really steep. Should -3 be really steep? Yeah. Yeah, I'm not going up on that roof. I'm scared of heights. It's okay. All right, so that's how we deal with 2 points. We have to find the slope. Now, what if I disguise your 2 points like this? I'm like, here's 2 points, but I'm not going to tell you what they are. An x-intercept of -3, that means -3 has to be paired with something. And anytime I give you the word intercept, that means it's 0. So a y-intercept of 5, that means the y value is 5, and it must be paired with 0. All right, so we got to find out what the slope is. All right, so let's go with 5 minus 0 and 0 minus -3 plus 3. Thank you very much. 5 over 3 is the slope. All right, now, did we learn our lesson from earlier today? I hope so. The y-intercept of 5, or this ordered pair, means I get to write my final answer here. Y equals 5/3 x plus 5. Done. Okay, so if I give you a y-intercept, please notice what I gave you, right? I want to make your life a little bit easier. Right? It might be a nice day out. Maybe you don't want to go and sit here and watch all this video. But that's part of what school is right now. So sorry about your luck. Okay. But if you can make it a little bit easier, and this is what I'm trying to point out, make it easier. All right, all right. Now, these have all been pretty nice because they come basically from a textbook where I made up a problem that would be really, really nice. But in the real world, things don't always work out that nice. So let's take this example from baseball just a little bit. Now, I do love baseball, so we'll kind of read through there. 1998, you guys weren't even born. I don't know, it's an old question, old book. Mark McGuire, he's that guy right there. He hit a bunch of home runs. This one isn't even about home runs. It's about runs batted in, the RBIs. So I'm drying out there. Okay, so after 40 games, he had 45 RBIs. After 86 games, he had 87 RBIs. We want to write a linear equation to estimate the number of runs batted in for any number of games that season. So we're going to use these two ordered pairs, and we'll start maybe with 87 minus 45. So I can start with 86 minus 40. All right. So let's go 87 minus 45. You might have to grab your calculator for some of this stuff today, okay? 87 minus 45, where are we at? All right, so we're at 42. And this is going to be, this one's 46, right? All right, now these are kind of messy numbers. Let's reduce it at least a little bit. So I get 21 over 23. Okay, so this is almost one. So that means he has almost one RBI for every game. So that's pretty good. All right, if you know about baseball, that's pretty good. So I have a slope, and we're going to pick one of these ordered pairs. Now, my mom thinks I'm really smart, okay, because I would pick the smaller of the numbers. Okay? Now, if I was super duper smart, I would use any numbers in here and use like the really big ones to impress her. But she's my mom, so she thinks I'm smart. It's okay. Y minus 45 equals 21 over 23. X minus 40. Thanks, Mom, if you're watching this. All right. So let's distribute that 21 23rds x minus, all right. So here's what we got to do. We got to do 40 times 21, and we're going to divide that by 23. Okay, so this is about 36.5 equals y minus 45. And this looks familiar now, right? We're just going to add 45. So y equals 21 over 23x plus, let's go with 8.5. We'll round it off a little bit. Mark McGuire won't mind. All right, so what do all these things mean? That means we're assuming for this pace, right, to make a linear equation out of it, his y-intercept means that at game 0, he had 8.5 RBIs. Right? That's not even possible. But that means that we could predict any number of games how many RBIs he would end up with. All right, quick addition here because I know you're loving baseball and what we're talking about here. There happen to be 162 games in a normal season. So based on this equation, how many RBIs would Mark McGuire have ended up with? Well, 21 over 23, 162 plus 8.5. So get that calculator handy. So 21 divided by 23. All right, we're going to take that times 162, and we're going to add on 8.5. So that means it should be 156.4, okay, RBIs in the season. Now, if that was actually going to happen, that would be amazing. I'll have to double check. We could Google that and see what he ended up with, but I don't think it was that many. That's pretty awesome. All right, so that was an add-on there. All right, so we do have an exit pass. So please give yourself a little space. Show me that you understand what we're doing here with this problem and by putting it off to the side. And we'll check that out as we talk virtually, in class, online, whatever it is. All right, peace.